Okay, so we need to create a Python function that will take a list of integers as an input, and it takes each 0 from that list and it shifts it to the end of the list. So every non-zero integer keeps its same order, but all the zeros get moved to the end of the list. Okay, so I've got a pretty simple idea in my head of how I want the function to work. So basically, I just want to iterate through each element of the list, and if that element is a 0, I want to remove it from the list and append a 0 to the end of the list, so that by the time I iterate through each element, all the zeros should be moved to the end. All right, so let's write this down in Python. So let me define the function here, and let's call it func with array as the input. Now, for I in array, if I is equal to 0, then we want to array.remove I, and then we can append it back to the end of the list by saying array.append 0. Okay, and then we can just return array here. All right, so let's test this out. So let's create a list here, and we'll print the output here. Okay, let's run this, and there we go. We got all the zeros shifted to the end. Okay, but let's really put our function to the test and see just how efficient it is. So first, let's import random. Then we'll import time. Then let's set the variable n to some large number. And what I want to do is create a random array that contains integers from 0 to 9 that is length n. Okay, so now let's create a start time. So let's say start is equal to time.time. Then let's call our function with our massive list as the input. And then after the function is complete, let's get our stop time here. And then let's print our stop time minus our start time to get the total time. All right, so let's run that. All right, so that took 26 seconds to run, but I think we can do better. Let's take a closer look at our logic to see if there's anywhere we can make some improvements. All right, so after thinking about this for a bit, I think I understand what's going on here. When we iterate through each element of the list, when we see a 0 and remove it, Python then has to shift every item that comes after it to fill its place. That means removing items from the list gives us the worst case time complexity of big O of n. So if we take a look at our function, the fact that we're looping through each item in our list, that by itself already gives us a time complexity of big O of n. And as we just saw, each time we remove an item from the list, that's another big O of n time complexity. And since we have a big O of n inside of another big O of n, our function has a total time complexity of big O of n squared. On top of that, we're also appending an item after it's removed from the list. So for every loop iteration, we're still working with a massive list of length n. Okay, so to avoid removing elements from the list within the for loop, let's take a different approach. What I want to do instead is I'm going to set a temporary empty list outside of the for loop. I also want to keep count of how many zeros we have in the list, so I'll set a variable equal to 0 here to keep count. Now, as we loop through the list, if it's a non-zero element, I want to append that element to the temporary list. Appending to a list has the time complexity of big O1, so we're good there. And if we encounter a 0 in the list, we want to add 1 to our 0 counter. After we've looped through each element of our list, we now want to take our temporary list up here and add a list of zeros at the end equal to the number of zeros we counted. So we get this as our output. All right, so let's go back to our script and implement this new approach. So let's first create a temporary empty list here, and then let's keep count of how many zeros we have. All right, so now let's say for I in array, and if I is not a 0, we want to append I to our temporary list. Else, if it is a 0, we want to increment our counter. And then after we've looped through each element, we can do t.extend z times a single valued list with a 0 inside. So then we can just return t here. Okay, so examining the time complexities here, we know our for loop gives us an automatic big O of n. This t.append operation is only a big O of 1, and incrementing z here is only a big O of 1 as well. And then this extend operation is a big O of n, but since it's outside of the for loop, it doesn't compound the time complexity to n squared. So looking at all of these, our overall time complexity for this function is just big O of n. All right, so moment of truth here. Let's see if we get an improvement on our last runtime. So let's run this. And wow, look at that, 9 milliseconds. That's an impressive improvement compared to the 26 seconds we got earlier. Alright, so yeah, I'd love to see what kind of solutions you guys come up with, so be sure to join the Discord and share with us, link below. If you like this video, be sure to show some love to the like button. Also, big thanks to the Bike Club members for supporting me. Thanks for watching, and I'll see you all in the next video.